I'm sure everybody remembers the event in 2011 in Joplin, Missouri. It was the most significant tornado event in terms of lives lost on record since the 50s. Did anybody make it down shortly after the event to Joplin? Get down there within the first couple months? A couple of people did. I did, and I took a couple of busloads of people. We were with an organization. We volunteered in the disaster zone for a day. And what really struck me about this, a lot of people talked about how it was a mile wide. Somehow in my mind I was reconciling, we're going to see a really good 1 square mile amount of damage in this community. And what I realized was it was all of a mile wide, and it went on for about 8 or 9 miles. So you start driving down the main drag, and then the devastation starts to get more and more and more and more. And then you get to a point where this hospital was, the old St. John's Hospital, that was ground zero. This is where it actually registered as an EF5. You can see here this precast structure, not a FEMA shelter, just architectural cladding on a steel frame. The damage was significant. All the windows were blown out, portions of the roof failed, they had some masonry walls on the side that collapsed, which hurt with egress. But the reason I consider this a success story is because if they had had a progressive collapse, a complete failure, then the 156 lives they lost in that community that day would have easily doubled. I mean, there was a tilt-up project down the street, a Home Depot, where the connection failed, the walls just fell like dominoes. So to give you an idea of the devastation in this area, I was standing here with my point-and-shoot camera, excuse me, I'm gonna put my back to you, and I took this picture from across the street, and then I turned to my left, which would have been this direction, and this is what I saw. That precast building was literally the only thing standing up in the area, and the devastation was so significant, it was indistinguishable whether it was a commercial or a residential district. So on a personal note, this is the team, part of the team that we took down that day. We cleaned out the residence of an elderly woman who lived with her adult son. They were there that day, really overcome with gratitude, and it just was a really humbling experience, made us sure appreciate what we had. One of my tasks that day, I ran a chainsaw for about 4 hours working on that tree that just literally just ripped right out of the ground like that. So not my typical weekend, but an interesting experience. So when they went to replace it, they started with the one thing that did work, which was architectural precast on a steel frame. Here's what they did differently. Instead of the big expanses of glass, they used, generally speaking, smaller punched openings. They tested a glass that could withstand 250 mile per hour wind loads being set into the precast with embeds that helped to secure that glass. The idea there was that the glass wouldn't be the first thing to fail, like that was what happened on the last project. Everything, all the egress areas were all precast. It's really changed the way that hospitals have been designed. And this is thin brick with some exposed architectural precast, integral color. So everything you see there except for the glass is precast. A similar story down the street. There was a Catholic church that was a total loss, but it got in the news a lot. I remember driving down the main drag and seeing this because the only thing standing up was that iconic cross. And I think that became a source of inspiration and hope that I would say even transcended the religious community. This was their groundbreaking ceremony. They were in a big hurry to replace that church, and the private school next door. So they wanted precast because of the speed, for the durability. They wanted people to feel safe there, but also they had a very specific look that they wanted. It was a Romanesque, traditional Romanesque look. So that was at the base of the church. There was some form liner work. That's actually exposed precast that was achieved with a rubber form liner. And thin brick. And then that's the main church. I'll tell you a lesson learned on this project, and that was, you can probably guess by looking at it, that would be the joints. We were not involved in the caulking. That was another trade, but to me, what was unfortunate that they chose such a light color. I think they were trying to match the exposed precast, but if they had chosen a gray, dark gray, or even a red, I think it would have popped less than what those joints do on that project. It's still a nice looking building. We're still very proud of it. But that was one lesson learned. That's the durability of precast. Who's ready for some meat and potatoes? Anybody? 2 people? All right. 3. I'll take it. Let's go. Some nuts and bolts ways that you as construction professionals, especially if you're involved early in the design, can control quality and cost. Here's a panel with a lot of things going on. It's a pretty complicated job, about as complicated as the one you and I did last time, Kevin, in terms of the panel complexity. But there is a exposed aggregate finish, there is a acid etch finish, there's things going on in 2 different planes, there's a curved lip, there's a grid pattern, lots of stuff. What takes something like this and makes it more cost negotiable is repetition. That is I can't overstate what a big deal that is in the precast industry. On an efficient job like this, a form liner that we can use again and again and again, form work is only about 3 to 4% of our overall cost, and that's our precast cost. So I would make the persuasion that you spend the money, if you can find some creative ways to repeat, then that is one way to save a lot of cost. And that repetition can go for a number of factors, for pieces, for form liner work. If there's a way to strategically find a way to make that form liner repeat and still make it look random, if that's the goal, whether it's pieces or not, it's a big of a deal because we can take our side rails and move them in and out, but there is some efficiency with the size of pieces when we repeat those. And here is kind of an interesting case study, the Perceptive Software headquarters, which is currently the Kiewit office, and that was originally designed as a column and spandrel job. So this was going to be a piece, this was going to be a piece, this was going to be a piece, this was going to be a piece. They had something else going on here. We realized that because of their flexibility with window sizes, we could do this with one large piece. So that's actually one piece, that's one piece, that's one piece. And you see a lot of bump outs, some thin bricks, some reveals, a lot of things going on, but because of the repetition, this was actually a very schedule and budget conscious project. And we cut the pieces by about 80% by going with those large pieces with punched openings. So that was a huge saver on that particular project. It doesn't always work out because people don't always have that kind of flexibility with their window size and their window locations, but it did work perfectly on this one. Some things that we suggest for working with precast. One is to get a precaster involved as early as possible. Sometimes that's when the designer's using a big fat Sharpie marker and deciding what materials they're going to be. Sometimes it's the CM will give us a bootleg set of CDs, say, hey, we're going out for bid in 2 weeks. Can you kind of give this the sniff test and see if there's anything glaring? Obviously, there's not as much we can do when we get involved that late. Usually it's somewhere in the middle there, whenever the team feels comfortable engaging us. Sometimes that's the architect. A lot of time it's the contractor if they're, very savvy on their precast procurement and, savvy about budgeting and that sort of thing. Speaking of budgeting, the more information we can get, the better. And some of these may not even be questions that you know the answer to, but one of the first things we're going to ask is it an insulated panel? Is it a non-insulated panel? Is it going to be a load-bearing panel? Or is it going to be clad onto some kind of structural frame like steel or cast in place? Is it going to be an integral color? Or is it more of a, a warehousing thing that's going to be painted in the field? Or will it have thin brick, thin stone? Then we'd like to take, instead of just talking about unit costs, we'd like to get even a napkin sketch of the building, a floor plan. We can start to panelize it and look at the efficiencies and give you a much more precise number than if we were just, say, parroting off, our unit costs from, the last few projects we've done. Does that make sense? Yeah.
Are these all exterior panels? Do you do any interior, like floors, like second floors or anything that tie into it? Is that all steel structures?
Yeah, so the question is, this is an all exterior envelope, and everything that I have and we'll show you today is, we do just exterior buildings. We don't do any floors in terms of just horizontal components. I mean, sometimes like parking structures will have double T's or hollow core, but the only real interior application we have a thin product that I'll talk about towards the end of the hour, and sometimes they want that same look to come into the interior of the building, maybe for an elevator lobby or something. So we have an ultra-thin version of our panel that can be hung on metal studs that we'll use for interior sometimes. Yeah?
And I guess you might answer this later, but when you're actually pouring them and you form them and you're going to manufacture them, do you work with like a different type of mix, like, or like is it fiber reinforced, or is it basically just we need 4,500 psi concrete, form it up and put it in there and move on?
Yeah, we have, our structural gray that we use is pretty consistent. I mean, we pour gray every day that we work, but then we'll also have typically, depending on how many projects we have going on, we'll have different color mixes that are pouring as well, and those vary. We've got, cream and buff is a pretty common color. Every once in a while we get into some more exotic colors like reds or browns, blacks, that sort of thing. PCI has a process where they pour, and we'll get into this a little bit later, they pour cylinders under identical circumstances of what's being cast in the bed, and then we take that and put it in a little compression chamber the next morning. We make sure it breaks, and when it breaks, we can measure the compressive strength. That's how we confirm our product's made strength. That's part of our certification process for PCI. So then, so here's a big one, and one that I thought about specifically talking, for this group, given the audience, striving to avoid overreaching scope of work items. Boy, we are really good at pricing precast concrete and precast concrete install. Another really good scope item for us is for us to, if we're doing the install, to do the grouting at the base of the panels. We have great sources for that. Another common thing that we do is the final cleaning of the building. That's actually something that I like to have in our source, because what I found, even if they say, we don't want you to clean it, we've got somebody who will come do a final wash. At the end of the day, whether people have asked for it and paid for it or not, everybody wants final cleaning before we walk away from the job. So we do like having that in our scope. Another item that comes up in addition to the install, the grouting, the cleaning, not as often, but we do it sometimes, is the caulking between the panels. We don't do that one as often because typically the CM or the GC will hire one caulker to do between the precast panels and then also around all the windows. Where we really start to lose our stride is when we kind of get into some more what I would call overreaching things. One we used to see a lot that we thankfully haven't seen is more is every once in a while they'd say, well, we want you to build a road and figure out your access for the crane. And we don't build roads. I mean, we just, it's a big guess and a big research project for us, and we're probably not going to do it as efficiently as somebody that does that kind of work does. So that's one we see every once in a while. The other one that's been coming up a little more often lately is for us to build railings on the job. And that is something typically with iron workers, those standards, they're going to have OSHA tie-off standards that are part of the regulation. But when we are building a railing on a project on all the levels, which essentially becomes the railing that all the trades use, we're getting a bit out of our lane as far as not really knowing those sources, not really knowing how that's going to work, not really knowing what the intent or the extent of those rails are, you know, based on the information that typically comes out of the time of the project. So, you know, that's one we prefer not to see. Now, if it's a situation where there's some railing and that railing is going to get in the way of the precast panel when it comes into place, maybe in, you know, one or two spots, and you want us to take responsibility for removing that railing just in that area, that's not as big of a deal, you know, as qualifying it and building the whole thing. But yeah, in that case, you know, you might be getting not necessarily your best precast price, but the best price of the precast combined with whatever they guess the railings were going to be. Because we typically run, I'd say, usually within 5 or 6% of our global competitors on bid day. And sometimes there's bigger swings than that, but it's fairly unusual. All that makes sense? We prefer, another one we've seen reglets. Sometimes they'll want those to be cast into the precast ahead of time. Now there's a lot of stuff that's no big deal at all to cast in, like electrical outlets, light switches, junction boxes, those sort of things. Reglets are tricky because there's a certain amount of precision that goes to that. This is what I'm talking about is where the roof is going to tie in, and the precision exceeds the PCI standard. So there's a challenge with getting those to line up. So we think, I'm editorializing a bit, but we think it's better if the reglets are cut in the field by others.
Do you provide embeds, or do you want to place your embeds for if you're coming up with rebar out of dowels, or do you just provide those?
Yeah, questions about embeds. Great question. I love these questions. Thank you. So we provide all of the embeds loose and connected related to the precast. So everything that goes into the footings and foundations, and typically what we'll do is when we do the shop drawings, we will expedite the portion of the shop drawings that has the embed design, because usually they're in a hurry to get footings and foundations in, and they need that information right away. What a lot of really savvy precast procurement people will ask me is, hey, can you tell me roughly how many embeds you think you're going to have on this job, loose embeds, so we can give a plug number to our cast-in-place guy. Now, it is going to be a plug number, because until we've actually engineered the job, we're not going to know exactly how many it is, but we can give you a general idea.
Now, do you verify, you shoot them in and verify they're in the right spot, or is that up to my cast-in-place guy?
It is up to the cast-in-place guy, but what we will do is our erector will come do a survey, and then, you know, we'll verify that they're in the right place before we come out with precast.
Before they pour? I mean, before the foundations are poured?
Typically not. I mean, we'll give all the locations. Yeah.
So then I guess that overlap, who gets blamed? Them, I'm assuming? I mean, you just gave the location, they don't put them in the right spot.
You're coming to work behind somebody who's done work that's integral to your work.
Right,
That's always a hairy, tricky.
Mm-hmm. Well, our engineering department will come up like with what's called a fix, you know, and they will make a recommendation for moving that embed or drilling another embed. Sometimes they may just leave the bad one in place if it's not in the way, and they'll just drill another one into place where it needs to go. So we will do the engineering for that, because we're giving engineering for an entire system and we want it to be right. But as far as, you know, the work, to put that in there, you know, that would be on the folks that didn't put it in the right place. Let's see, being creative with the aesthetic possibilities of precast, that's a little bit more for the designers. Visiting a precast production facility, if you ever get a chance to do that, we've got a plant in Omaha. We'd love to have any of you up there to do a tour. Typically, if you're working on a precast project, we'll schedule, something around the time of either when they're pouring the mock-up or the first couple pours of the panel. We'll take a little virtual tour of our plant today, and you can see what that looks like. But that's something that we strongly encourage. And a little bit about schedule. When it comes to precast, we do all kinds of projects. We do hard bids, read them and weep. We do negotiated. We do design build. We find ourselves being pretty big fans of design build for a lot of reasons. One is because it fits into, one challenge you have with precast is getting into their schedule. And some precasters book out a little further than usual. Typically it's, if you're not out if you have an empty plant, it's going to take 4 months to get precast because that's how long it takes to get through the shop drawing process, the engineering process, the sampling process, and then to start production. And have enough pieces produced to get it out to the job site. And you got to be at least 80% produced because once that crane gets out there with the union workers, you got to feed that monster, make sure they don't have any gaps in their schedule. So, it would be 4 months if there was no work. Typically, precasters will want to book at least, 6 to 7 months out. Now, some precasters are booked, a bit further than that, for us, and I believe my Novo competitor, we're at about 8 months right now. So that's something to think about. And where that gets really tricky is on the school jobs where they're hard bids. With the design assist delivery, when we get involved early, and people that are pretty sophisticated about their procurement will often have us budget a core and shell package and sometimes choose a precaster from that exercise, whether they're working with one up front or whether they're working with 3 up front. And then it becomes a job where the precaster is actually helping the designer to make the most efficient design possible. Here we lock it down based on a certain set of assumptions that are very well qualified, and then that price can go up or down, based on what happens, but it's an open book job. It's an understood set of parameters, and at that point we've locked down a unit cost that we're staying within striking distance of. And then you can save time on the back end of that. And then there tend to be less surprises than with this sort of process where there's change orders at the end, questions, assumptions clarified, and things like that. Does that make sense? And then here's another good one for a group of estimators and project managers. Precasters have a little bit different way of doing takeoffs. Some do this, and this job has a little bit of everything. It has some vertical panels, it has some panels with punched openings, it's got some base panels, it's got some upper spandrel panels, some overhead panels over windows. The different colors you see, that's just our way of verifying whether it's a different form. That's how we track the repetition of our form work. But a few questions to ask. There are some precasters that are very loose, and when they're doing wall panels like this, they won't even figure the punched openings in there. They'll just throw that cost in there. We're a bit more precise than that. We will subtract out the punched openings when we're doing a project. So that's a good question to ask, just to make sure that their takeoff process aligns with yours. The other thing that causes a little bit of confusion every once in a while is there are some precasters that when they figure square footage, they figure it based on the square footage of finished product. So that includes maybe there might be a little bit of return back where that window is, where the precast is tucking back, and you've got another 6 inches or so of finished area. So that's a good question to ask, and if you want the precaster to take that number and qualify it to just the amount of flat panel, they should be able to do that for you. So that's, yeah, and that's just a typical blue beam takeoff that was done for a little project that we're doing in Johnson County right now for their new medical exam building. A couple of VE case studies. This was a parking structure. The design came in. None of us have ever had this happen on any of our jobs. It was over budget. The owner asked for a VE exercise. This was kind of in the early days of BIM, when BIM had a little bit more wow factor. Now everybody uses it, but looked at some ways to make that thing more efficient, make it a little more boring. Realized we could save about 18% of precast costs just by straightening. Now, that didn't end up being that much, so sometimes it's just a justification for the owner that, you know, it's really not that more expensive than what they had before, but they have the satisfaction of running the traps. One of the most successful VE stories that I've been involved with, it was with my last company. There was a design build competition. The team that my company was on won that competition. When they got the job, they realized that it was $1 million over budget. It was a $12 million parking structure. So they said, usually when you have to take some money out of a job like that, you've got a little bit of wiggle room. But in this case, they said, well, we got to have this many parking garage spaces because it's in the program. You know, they need this retail space because that's in the program too. You know, we sold this brick design and this architectural look. So basically, we just need to do that. We got to figure out a way to do it $1 million cheaper. And I'm not exaggerating. So the contractor, the precaster, the structural engineer, and the architect locked themselves in a room for a day. They came up with a gentleman's and ladies' agreement. They were going to check their egos in the door. All ideas were on the table. They started looking at it and realized with the floor plate, instead of going with a 10-foot double T, if they went with a 12-foot double T, they could actually spread that out and have less pieces. So that was less columns, less beams, less floor slabs. There was some savings there. Then, with some review of the codes, it was discovered that you only needed 3 stair towers in this building. So they eliminated one of the stair towers at the far end of the building. The other thing that they did is they realized there were some areas where you had precast on top of precast. So you had structural precast with some architectural gingerbread on top of that. And so by combining those into one component, they were safe. So at the end of the day, that one-day exercise, they ended up saving that project $900,000. And it was a successful job. I should have a little asterisk here and say results not typical. That was a good day. Some other recommendations. Oh gosh, the sound didn't work before, but it works now. Hang on just a second. There we go. Much better. Everybody doing all right? So we encourage a PCI certified producer. The Precast Pre-Stressed Concrete Institute has a certification program. That means that producers get at least 2 unannounced audits per year by independent inspectors. They come in, they check the reinforcing strength, the curing strength, the quality, the finish capability, safety, all those kind of things. It is the largest, most stringent, and widely accepted regulatory agency in the precast business, and I would say probably 85% of the producers belong to PCI. So it's a lot to maintain those standards, but we feel we're better for it. The industry's better for it, and we just encourage that you require that in the guidelines. And be careful about the verbiage. Sometimes you'll see specs that say, we'll meet the standards of PCI. And basically, any mom and pop operation can raise their hand and say, hey, we can meet those standards. Look at these jobs we've done. We're good. But everything in that product is concealed. And unless they have those independent inspectors from that agency doing all those testing, there's just no way to know. There are some alternate certification agencies, but PCI is the most stringent. So that's my PCI soapbox. Then we encourage a thorough sampling process that requires the submission of large mock-up panels prior to the casting process, prior to casting panels. So a real bad day in this industry is when, about 10 panels show up and you're out at the job site and the architect says, I'm not sure if I like that. And the owner says, yeah, it's not really what I was expecting either. And that's where that sampling process comes in. We really encourage having being part of that sampling process. Little finish 101. The most common finish in the industry is what's called a sandblast finish, followed by acid etching. Acid etching is really practically overtaking sandblast now. With new, there's some new EPA guidelines that make sandblasting more difficult to do, particularly on site remediation because of the silica standards. So where sandblasting used to be a little bit more cheaper than acid etch, I would say that is flipped. Acid etch is probably a more economical way to go, and I actually think it looks better, just the old designer in me. Then they have the exposed aggregate, the rough rock look. That's the first time I ever saw one of these samples when we got in the industry 15 years ago. I thought, 1970 called, they want their finish back. But as I got into it and looked around, I realized this is done quite often, usually on the base of the building. And then there'll be a transition with a reveal, and you might see sandblast or acid edge up above. And polishing we don't see so often. That requires a specialty polisher to come into your plant. While it's very common and easy to do on floors, on vertical surfaces, a little bit different animal. So we get some interest in that for samples, but it seems at the end of the day, it's pretty rare people want to spend that money to do that. But one way to save money, this is one mix design, this gray. This red is one mix design. You can divide your wall with reveals and you can distinguish with texture instead of distinguishing with mixes, and that saves a little money. We can pour more than one color, more than one mix design in the panel, but there's a cost for that because we're essentially doubling the risk that something will go wrong with one of the two mixes. And then there's a new finish that we do called a distressed finish, which we have something that we throw down, and then a powder that we throw down in the bottom of our production bed, and it gives it this veiny, distressed look. Well, if you break that up with reveals, it has a look of natural stone and travertine, but just for literally a fraction of the cost of doing a natural stone job. So that's something that we're starting to see some interest in. For precast samples, something that we encourage doing during the sampling process, whether it be with the designer or the contractor or whoever is actual samples. In this particular project, I thought, I know Brian, my friend and competitor from Course Labs here, I thought he might be here today. I'll tell a story about him. He won't mind. Is he? Oh, I know he's here. I thought, yeah. Anyway, I've told this story in front of him before. He won't mind. So basically, this is a little bit different project. I'll tell you what, I'll tell the story first. It may seem like if you're working with one precaster and they're doing all your samples, you're giving them an advantage. And that can be the case, but it's not always the case. A few years ago, I was working for a different producer. Brian was working for Course Lab. we were working with an architect on a school in Osawatomie, Kansas, and we were doing all the details, we were doing all the samples, making trips to the site, kind of doing some light design assist coordination at risk, because it was going to be a school job. Brian was doing the same thing for an architect for a school in Baser. Both jobs were schools, both went to a hard bid. My then company, IPC, got the job in Baser. Course Lab got the job in Osawatomie. We went and matched all their samples. They went and matched all our samples, and it went just fine. I mean, I think those jobs bid within 2 weeks of each other. So that does happen. But in this case, this is a different circumstance. We got a picture from, there's a book called the PCI Color and Texture Selection Guide. We did a sample. The designer said, yeah, what we'd like to do is get more dark aggregate in that. So then we did another sample. And they said, okay, we like that better, but we'd like it just a pinch darker and a bit more intensity on the dark aggregate. So then we did this sample. And they said, that's perfect. That's exactly what we want. They showed it to the owner, got approved, and then that sample and that sample number and a picture of it went out in the specifications to all the bidders. The reason that's important is because if it was just the page from the PCI book, which is kind of general and generic, everybody would have assumed this. And even though this was not a budget buster, with that darker admixture and the extra black granite, there was definitely a cost difference between these two. So this way, you're not sorting that out afterwards with change orders and things like that. Everybody knows exactly what they're walking into. So that's another benefit of samples. And then of course, markup panels. They're great because you can show not just a larger portion of what the sample's going to look like, but you can start to get into what the reveals are going to look like, the transition from the thin grit to precast, the height of the reveals, the depth of the reveals, that sort of thing. So the architect's obviously always involved in that process. We like when the owner gets involved, usually. I mean, and just everybody's talking about those expectations up front. Anybody falling asleep? I might be. I'm going to throw some stuff at you guys. Nobody's thrown anything at me yet, so. This is like your mid-afternoon wake-up call. Nobody's sued me yet, so I'm going to keep throwing stuff. I broke my arm last year. Throwing's a little bit weird for me now. I made it back to the cheap seats. Almost. I got some paper too. I got some paper, pens, stuff like that. So this is a very general chart. You know, this is for those times we got to save some money. We don't know how, but we got to save some money. It's fairly generic, but basically everything you see to the left, the further you get to the right, the more expensive it's going to get. The upside of that is the further you get to the right, the more control you're going to have over the final appearance. So precast is one of those things where you don't want to always automatically run to the cheapest option, because that's not necessarily the best option. For instance, insulated precast concrete is probably going to be maybe $5 or $6 more than non-insulated, but then you're getting a complete wall system and eliminating a lot of trades. You're not having to worry about continuous insulation requirements and things like that. So I personally, I think insulated sandwich panels are the best precast value in the market. White cement is going to cost more than gray. I would also advocate that's money well spent, because you're going to have, unless you're doing a warehouse that's going to be painted, you're going to have so much more control over the final appearance and being able to sell that job. Now, I can tell you where you're really going to save some money is with aggregates and with rock. And that is if you show the sample and tell the precaster, do a version of this with locally available aggregates. They're going to use aggregates that are locally available to them and all their competitors. So they will come up with a sample that I'll bet is going to be pretty darn close to the picture that you see. But, you know, where you start to, you know, black granites are fairly negotiable, but then when you start getting into quartz and white marble and exotic rock, that's when costs can start to spiral. And the most expensive thing you can do is hard spec a mixed design with a rock that only exists in another part of the country, and they've got a truck aggregate all over the country to get that done. And really the only way to know this is to be working with a precaster up front and have them involved in that sampling process and have them give you that heads up. So that's a big deal. Pigment is a pretty negotiable cost. Obviously, the more you use, the more expensive it gets. Flat panels are less expensive than reveals, which for us, we have carpenters on staff, reveals really don't even impact our cost. Form liners are certainly going to get into some cost, but depending on how strategic you use them, how much repetition, that cost starts to become a little more negotiable. Then, you know, you might have a custom form liner, like we did for KU, image of Gail Sayers, a famous football player at the front of their athletic facility, and that was a one-off. So it was not inexpensive, but it was the most visually prominent area of the building, so it was something that was worth it to them. And then, you know, there's some cost with projections. Here's the chart here. I would actually flip acid etch and sandblast now, because I think sandblast is less expensive than acid etching is less expensive than sandblast now, but exposed aggregate, there's an extra step because there's a chemical retarder painted at the bottom of the bed. We talked about the single mix designs versus multiple mix designs in the same panel. That's a way to save money. Now, if you've got more than one mix design, say you've got two colors but they're segregated by panel, that's really not a big deal. Years ago, we did a project with Terra construction up in Briarcliff that had more than one color, but it was segregated by panel, and that job has a lot of arches and, you know, what I call gingerbread on it, but there's so much repetition. That was actually a very schedule and cost-driven job, and highly successful. And then applied color is less expensive than brick, which is less expensive than terracotta, which is less expensive than stone. So another way to, when you're involved early enough, and you're not always involved this early, I know sometimes these decisions have been made, but when you get the benefit of being involved early, another thing to look at is composite versus non-composite wall panels, if you're doing an insulated sandwich panel. So the difference is the old school way of doing things is what's called a non-composite panel, and that's where you have a big fat withe of concrete that is doing all the loading, all the lateral loading, all the structural responsibility. It's tied together by some kind of non-conductive pin system, and then you have a very thin surface layer that's just there basically to serve as a moisture barrier and to look pretty. And that's an okay way to do a building. And there's times you want to do it this way, if it's a FEMA shelter or something like that. Another way of doing things is what's called a composite panel. In that case, you have equally spaced withes of concrete that are each sharing in the loading. And in that case, it's acting literally as one panel. And all things being equal, that's a pretty good way to go, because what happens is, with less concrete, you're able to do the same thing from a structural standpoint. In this case, we had 8 inches of concrete, 4 inches of insulation. This one was 9 inches of concrete, 3 inches of insulation. They were able to sneak an extra inch of insulation in here. They offset that more expensive concrete with less expensive insulation. It yielded a higher R value. It made the panels weigh less. When the panels weigh less, you can size the crane down a little bit sometimes. Sometimes it helps you to consolidate your loads. Maybe you can get 2 panels on a load where you wouldn't have been able to before. So what that ultimately results in is lower cost with composite panel design when the parameters allow for that, which in our case is most of the time. We do mostly composite panels. Everybody's looking for the most efficient way possible to build a building. So here's some typical details for a load-bearing building. One way to do it is to put a metal angle on here, have the roof bear down. Another way is to pocket. Similar concept with a non-load-bearing panel. It might have some kind of slotted connection that may intercede in the panel at some point, but it's essentially connecting to a floor slab and a system that is supporting itself. We do a lot of, actually do quite a few non-load-bearing panels. The other way that non-load-bearing panels fits in is with precaster schedules, because typically precaster, if it's a load-bearing panel, precast is going to be one of the first things you need out there, and that can create a challenge. So with load-bearing, non-load-bearing, there's some stuff to do ahead of time. Another thing to watch out for during the shop drawing process is if you have equally spaced slices of concrete, there will be a circumstance where you have to put in an embed or something like that, and you might not have quite enough room in there. So what happens in that case is you can actually notch into the insulation, and it's perfectly fine to do that. The key is to not break it. If you completely stop the insulation and restart it, then you don't have that full thermal break. Then you start getting into average R values and a real slippery slope. This one is more for the designers, which is something to be aware of. There's different ways to break up the panel. The most common way is a butt joint. Then we can sometimes dress that up with a miter joint right on the corner. The L-shaped piece is a little more expensive because it's a two-step process. We'll pour one side on one day, one side on the other day. Sometimes they have a very visually prominent corner and they don't want to see a joint. Other times, if you're doing a thin brick project, you want to do the butt joint because they make corner pieces for thin brick. And part of the illusion is seeing that brick on the corner there to give the illusion of it being a full brick. So you definitely don't want to do a miter corner on a thin brick job if you've got brick coming up to that corner. How are we doing on time here? I'll tell you what, I'm going to kind of breeze through the show and tell here because I want to take a little time to pour a wall panel. This was a job in Lawrence. Insulated panels. This is a job in Wichita with some form liner work. St. Louis, job at a software company. Hospital here in Kansas City. I'm a K-Stater, so I always got to show something K-State. No Wildcats. Any KU guys here? Really? Okay, few. All right. I gotta admit, I'm not really looking forward to that trip to Allen Fieldhouse. I think you guys are going to be out for blood.
You beat us a couple days ago.
Yeah. I'm trying to live in the present tense for now. Those wins mean a lot. They're few and far between. There are different kinds of thin brick, standard, modular, and utility. Wide variety of colors, so I've really never had an issue with trying to match an existing building. They can do customs as well. I mean, if you get up really close, you're going to be able to tell, but, they definitely have adequate curb appeal. It's really gotten to a point where it takes an educated eye to know the difference. A lot of people don't think of precast for retail, but it has a retail application. It's been done on stadia. Obviously, this was a thin brick project. This was a school that had to match a brick and cast stone project across the street that was on the historic register with thin stone. That is something, this project they couldn't meet the budget or the schedule. It was a $75 million project. So they switched it from masonry, from limestone to a thin limestone set into precast, and it came in on time and $3.5 million under budget. Well, that's the courthouse in Jeff City. Really nice looking job. And the way that works is with brick and with terracotta, it can be cast right into the precast. And when it's a clay-based product, you know, it will expand and contract and work out just fine. When it's a natural stone, it's a little bit different animal. You have to maintain some separation between the precast. So you put in what's called a bond breaker and then some stainless steel pins. Here, this gives you a little bit more practical visual of how that actually works. And usually the pieces of stone are about 1.5 to 2 inches thick. They come pre-drilled. We put the pin connectors in there, the bond breaker, pour the concrete on top. Here you can kind of see how that works on an actual piece with varying thicknesses. And that's what that piece looks like actually on the building right there. Go back to that. You can see it on the building. A few of these you probably recognize. That shows you what you can do with bump outs and protrusions. Here's one we're really proud of, and just one of the best mixed-use project of 2019 by our regulatory agency, PCI, and they only give out 13 of these awards a year in the United States, so it's a pretty prestigious honor. All the precasters only submit their very best precast jobs. And this one had a great use of some deep form liner. It tied into Sporting KC's logo and branding. They're shared tenants with Mercy Health and not Mercy Health, which hospital is it, Kevin? Children's Mercy, thank you. And also the USA Soccer Association. There's basically 3 tenants in this building. But great use of form liner on this project. Something they really wanted to make a statement. And that's a form liner job. That's not a thin stone job. That's actually a form liner, so that's an optical illusion. You're looking at exposed precast there. Sometimes we'll actually sandblast the inside of the panel and leave it exposed, similar to when we did Jay Dunn's office. It had a kind of modern day loft feel with an exposed cast in place ceiling, so it worked really well. We're actually doing a lot more of this these days. So curved panels, there's an application for curved panels. How am I doing on time here? Got a little bit more time. We'll pour a wall panel real quick. The thing I love the most about terracotta is you can spell it 3 different ways and still be correct. Very helpful for a guy like me. It's similar to brick. It is a clay product. This project was originally envisioned as a terracotta rain screen on a steel frame with an air barrier and a conventionally built wall behind it. They found out that was going to cost, somewhere in the $90 range per square foot. We were approached about doing precast and casting that terracotta into our precast. At that time, it had been done in Europe, but not in the United States. But the terracotta came with these little groove backs that bonded with the precast, and then had a little shiplap joint within the terracotta themselves, so there was like a little shadow there. The nice thing about that, the precast stopped here, so here you actually didn't see grout at the edge. You saw a little shadow, just like you would if it was a rain screen on a steel frame. But this is back when continuous insulation requirements for ASHRAE had just come into effect and was a pretty big deal. So this system fits into that. This is our plant manager, Gary. We had a 5-color random blend, but there was nothing random about it from our standpoint. B&IM told us, put this color here, this color here, this color here, this color here. So we took no chances. We had color-coded instructions in our plant. And then that's a 12-foot wide panel, so each of these is 4 feet. Here you can see a block opening there for a window. They put down some reinforcing. They put the first layer of concrete down, the first wipe. Then they smooth and vibrate that into place. That's critical to keep the mix fluid, get it settling in all the right places. Then they put the insulation down. And in this case, that insulation was connected with what's called C-grid, which is carbon fiber reinforcing grid. And then a layer of wire mesh was put on top. There you can see the lifting loops on the side of the panel. Cast-in electrical, that's for the inside wall, so they've got some power outlets that will be nice and flush with the wall. There you can see a little gravity connection on that panel after they poured the second wipe. And this was, we were talking about this earlier. This was that's the cylinder that they produce that is under identical circumstances with the same mix. The next day they go in, it's going to cure to about 3,500 psi within 12 hours, which is enough to extract it out of the bed. It's technically still curing for another 28 days, and it's going to settle somewhere between 5,000 and 7,000 psi. So we'll do 2 cylinders. We'll do a 12-hour test, and we'll do a 28-day test. Very, very rare that we'll have a panel with that big strength, but it has happened before. Day 2, they prepare for stripping or extracting that from the production bed. There you can see that terracotta at the bottom of that panel. Here they lifted it up. There's an internal rail system in our plant. Then they put it out in the yard for cleaning and storage. This was a 4-story cast-in-place building with an atrium. There you can see those panels start to go into place on the back wall. There were some areas where these were just sandblasted and left exposed. You might remember that gravity connection. A lot of times we will pocket that gravity connection in the cast-in-place slab. There'll be a little notch. In this case, we had the luxury of knowing there was going to be a raised floor for HVAC and electrical, so we were able to just leave it exposed, knowing that there was going to be a floor on top of it. There you can see it from the outside. Starting to go into place. There's some construction photos. And the reason the random blend was not so random is because this was this contemporary structure on a traditional masonry campus, but all of the brick buildings were out towards this side of campus. The limestone buildings were on this side. This represented a dividing point. So this wall and the elevation behind it had more reds. These 2 elevations had more cream colors. That's why that worked the way that it did. And here's some final pictures of that project. It had a little curved piece that they put on the end. That was field installed. So with Precast, you have a lot of, with general construction, you've got a lot of different things going on. You've got a lot of different trades, a lot of people on site, a lot of schedules, a lot of things that can go wrong. With Precast, you've got a very streamlined, consolidated process where you can rely on one vendor. And it's something that is not really something that is really considered even an alternative method of construction anymore. And for the right project, it can really be a great solution. And that's, I think we're gonna, since I'm coming up on my time here, we may skip the new stuff here. This base, I'll just tell you real quick, we'll do a thin rain screen panel that is 1.5 inches thick. This is for high-rise buildings, for lobbies, elevator lobbies, things like that. We are actually just coming out of R&D. We're coming up with a thin wall panel system now, where we're going to have these 1.5 inch panels on each side with insulation in the middle, and that's actually the one I'm really excited about. I think that's going to be the game changer, is our new insulated thin wall system. But we also have the solid cladding that can work as a lightweight rain screen. It's pre-stressed. in two directions, which is a lot how we're able to make the precast so thin. It goes onto the structure usually with a clip system, and then there's pockets of insulation in between. There's an example of our thin wall. And then graphic concrete is something we're pretty excited about. That allows you to impart any image onto a precast concrete structure. This is a school in Murfreesboro, one of the first in the United States. They've been doing this in Europe for about 15 years. It's a tree pattern. And this is, the level of detail, this is a project in France, but this is actually, you can do a person's face, and it's a detailed, etched pattern. And the way that works is there's a membrane of paper with a chemical retarder, and that's put down in the production bed. The precast is put on top, and then it's put in the field, and wherever that positive negative is, it doesn't cure, so they can wash it off and it exposes the rock. And everything's going to be grayscale, but it allows you to do a lot with different designs. And the cost, if it's efficient, it can be just a little bit more than thin brick, so it can be pretty cost negotiable. Where it gets expensive is if you have a one-off, like you just want to do one panel with a person's face, because there's a certain amount of setup cost. So that, in that case, it would not be as economical. But I am right up on my time here, but I wanted to leave a little bit of time here. Did anybody have any questions? I must have covered it all. Okay, well, there's a sign-in sheet going around. If you want to sign it with your company name, your email address, we'll get you some certificates. And hey, I appreciate everybody showing up. If there's anything I can help you out with on anything, please let me know. And I hope I got through talking before you got through listening. Enjoy the rest of the day.